Okay, we're going to continue with 3.2. We didn't get to the intermediate value theorem. And so when you look at this, it's kind of a little on the confusing side. Basically what it says is, if I have two values, A and B, that are not the same, and if I plug those two values into a function, I'll get different values, theoretically, okay? So if you'll notice on this picture, if I plug the A in, the result is f of A, which is this point right here. If I plug B into this function, I get this point here. So A has some value, f of A has a value, and f of B has a value. Well, if this function is in fact continuous, there has to be another point in between them, right? If it's continuous, that's true. This is useful when finding zeros. So here's the intermediate value theorem in words. Y'all have a moment, want to pull this back up and read it on your own, you can. I tend to just kind of gloss over it. So here is a useful use, I guess, for the intermediate value theorem. I've got a function, f of x is x cubed plus x squared plus 1, and I want to know where the zeros are of this function. Well, if I plug in a -2 into that function, I get a y value of -3. Notice the y value is negative. If I was to plug in -1 into the function, I get a y value of 1. So what happened? The value of y went from a negative number to a positive number. Continuous, I guarantee there must be a zero between -1 and -2. That's what the intermediate value theorem tells us. Okay, does that make sense? There's no way to get from -3 to 1 without going through 0. Okay. Because I know that there's a 0 between -1 and -2, I could choose other values between -1 and -2 to kind of zero in on where that actual 0 is. Okay. And this is what it's going to look like. So same function, right? Nope, they changed the sign on me. Okay, different function. I'll get there in a minute. Here's my function, x cubed minus x squared plus 1. I want to try to find a 0 of this by using the intermediate value theorem. So y'all use the calculators and help me out here. What is f of -1? If I plug in a -1 into this function, okay? If y'all would, someone please plug it in, or just do the math while I'm writing down the equation and tell me what the answer is. -1. So if I plug in -1, which tells me the point -1, -1 is on the graph, correct? If I plug in 0, well, when you plug 0 into a function, all you have to do is ignore all the terms that have variables in it, right? And I'm left with 1. So the point 0, 1 is on the graph. Can you tell me where there might be a 0 to this function? Based on that information. Do we know anything? Is there a 0 between x values of -1 and 0?
Teachers, please release.
No, wrong answer.
Now.
Try it, get out of here. Okay, look at the y values. Do the sign change? Do the signs change? Okay, so is there a 0 between 0 and -1? There has to be. There has to be somewhere in here, there has to be some x value that gives me an output of 0, doesn't there? Yes, that's the intermediate value theorem. Well, Okay, well, let's narrow it down some more. I know based on this that there must be a 0 between 0 and -1. So I'm going to choose a number between 0 and -1. How about negative 0.5? Is that between there? Okay, someone please put that in your calculator and give me the correct answer. Okay. I've got a 0.625. Do I have a second on that or a different answer? Not that you're wrong. I just want to get a second opinion. Well, you can fix that. You know where they're at. Cubed and then squared. Okay. Okay. So now look at what we have. I've got a negative value there. I've got a positive value here. So at -1, we get -1. And at 0. Nope. Yes, negative 0.5, we have 0.625. So do we have a sign change here on the y values? Yes. So now instead of saying there's at least one 0 between -1 and 0, I can now say actually there's at least one 0 between -1 and -0.5. And we could continue to do this process and get closer and closer and closer to that 0. Okay. It is. So this is an intermediate value theorem. I'm going to, if you're screenshotting it, go ahead and screenshot it because I'm about to clear the screen. And then I'm going to remove the box so you can screenshot the text from the book. Good? Okay. Are we good? Annotation is now gone. Box about to be gone. Oh, thank you. So here's what they did. They plugged in -2, then they plugged in -1, then they plugged in 0, and they plugged in 1, and we know there's a 0 here. Now listen to this. There is at least one 0 between those 2 points. That makes sense. There could be more, right? It could go up and down a whole lot between those 2 points. But I know for sure there's at least one. Next slide. If we plugged in -0.8, you would get -0.152. If you plugged in -0.7, you would get positive 0.167. So now I know that there is a 0 for this function, at least one, between -0.8 and -0.7. So you see how it's getting closer, right? So there you go, intermediate value theorem. Here is a graph of the function. And by looking at the function, it makes sense that somewhere between -0.8 and -0.7, there does in fact exist one 0. Okay. If we wanted to keep going, we could have plugged in maybe -0.75. And we could have gone on and on and on as far as we wanted to see how close we could get to the actual 0. And I'm going to not do the practice problems for this section simply because we need to go ahead and move to the next section.